onto the coin and lean game. Here's a story for you. Somebody's phoned up Freedom and they wish us to set up a production line flipping coins. The reason is they're going to go down to Sky City, and they think if you flip a 20-cent coin 4 times with one hand, that it's auspicious and good luck, and you put it in the poker machine and you'll win. So they want us to flip thousands of coins. It's true. Anyway, so what we need is 4 workers who are going to set up this production line here, and each worker is going to flip the coin once. You've done this before, haven't you, Sandra? No. So we need 4 workers. Who wants to be a coin flipper? Everybody gets involved, by the way. I thought so. 1, 2, 3, 4. Great. So if you 4 could grab a chair, or these chairs here, and just line them up there on the production line. 4 times. So you've got 4 people. So you're going to flip it once each with one hand. So could you just count 20 coins out, please? 20, yeah. Now, we can't be trusted, can we? Money's involved, and also we need managers and supervisors. So what we need, I'm glad you've got your phone there, mate, because we're going to need to time these people. So there's 1 manager, 2, 3, 4. Have you got your phones with you? Great. Another manager, if you can grab your phone. I want you to stand behind a worker, and you're going to supervise your worker. So the 4 managers stand behind the worker. Now, don't feel any pressure here, but your bit is dependent on how fast you go, and don't be the slowest person. So we've got 4 workers, we've got 4 managers. The managers, you're going to time your worker, and I want to know how long each worker took. So remember, your bonus depends on it. We also need a customer. Who's going to be the customer? You look like a customer to me. Come over here, mate. You got your phone?
Yeah.
Great. So I want to know when the whole 20 coins get to the end, because that's when you get your delivery. So we're going to see how long it takes for the whole 20 to be flipped and over to the end.
All of them. Yes.
All 20, yeah. Who's not involved yet? We need, we need a planner, and we need a BA as a planner. So you've not done this before?
No.
Great. We're gonna need somebody else in the next round, so just hold fire at the moment so we all get involved. So, firstly, let me just demonstrate so you understand. So what you do is you've got 20 coins and you flip all 20, like that. And when you do all 20, you pass them over, and then you flip all 20. You're going to time for your worker just for the 20, from the 1st to the 20th, and so on and so on. You time from the first coin being touched here to the last coin being flipped over there. And you're the planner, and we don't do any work here without planning it. So tell me, how long is it going to take for all 20 coins to be flipped 4 times? And by the way, your bonus depends on it.
Right, okay. Let's say 2 minutes max.
2 minutes max. So you're going to put 2 minutes down? How do you feel about 2 minutes? Any pressures? We'll put 2 minutes here. Who knows? Who knows? Best way to find out is to actually do it, right? You all good to go? Ready to time? You good?
Yeah.
3, 2, 1, go. Now, managers, your bonus depends on your worker. So GMO, click fingers, tapping, supervisor, actively. So it's got to be 1 hand. It's got to be 1 hand.
It has to be 1 hand, and I just put it in. It has to be only 1 hand.
There's only 1 hand. Doesn't work with 2 hands, right? Oh, there you go. There you go. And off you go. And your manager, you should be now G and give up. Remember? When there's more people,
Thumbs up.
that will not work. Anyway, keep going, keep going. Give me your, tell me when you finish it so I can deduct it. Well done, keep going. Brilliant. Stop. Well done, team. Let's see how fast we did. Worker number 1. How long? 24. Therefore, I'm assuming your stopwatch stopped, did it?
Yeah.
Don't worry, because it was 47 when you finished, which means you'd have been 23. That was lucky. Sometimes people forget to start, don't worry. What were you?
23.
23? Oh, it's all even and balanced, everyone's the same.
21.
Oh, look at that, rockstar, mate. Now, the question is to you three, why didn't you do 21? If he can do it, why can't you do it? What's going on? Right, so, let's do this again. Take this to the beginning, put it here. We're going to try it one more time. This time, it's going to be 2 batches of 10. And what that means is, so you could just split them into 2 10s.
What was the total?
Oh, yeah, sorry, thank you, David. What was the total? 1 minute and 36. So, Sandra, what went wrong? You well overestimated that. 136.
It was new work.
Oh.
I didn't know how long it would take.
Oh, well, that's your planner. You're supposed to know how long it would take. Right, that's okay. Well, maybe next time you'll do better. Only two.
Thank you.
Right, so this time, 2 batches of 10. The workers, you're still going to flip 20 coins, but you'll do the first 10, and as soon as you see a batch of 10, you pass it, and you can start. You're still going to time your workers for the whole 20 coins. You're going to measure all 20 at the end. And who's the final worker? Who's the final supervisor here? Right, I've got a job for you now, mate. What we'd like is for you to time when the first batch arrives. So in this case, there was 20 that arrived in 136, and the first batch was 20, so it's the same number. This time, we'll have when the whole 20 arrives, but also when the first 10 arrive. So you're going to measure when the first 10 arrive. Come on, mate, it's all right. It's okay. So, you all good to go? You know what you're doing?
Yep.
All the same? Now, I want to see some passion in this. Yep, David?
Do you need an estimate?
Thank you. I'm glad David's here. Estimator, you thought you were let off the hook there. So, it was 136 for this. What's it going to be for 2 batches of 10?
I would say 50 seconds.
50 seconds. Sharp intake of breath. Now, if you miss, if you overshoot, you was fired as a planner, and I'll blame you as well, right? So, and supervisors, make sure your workers hit this. What did you say, 50 seconds? So, wow. Wow. Let's see how it goes. You ready to go?
I am.
And go. Look at this now, he's onto it now. You can see he's trying to improve. This is what pressure does. You've got to manage people. Well done. Manage what you're doing. You know, flick your fingers, get going. Oh, definitely much faster. Well done. Awesome. One at a time, doesn't work otherwise. One at a time, one at a time, one at a time. Otherwise you screw up the numbers, mate. Our customer was very specific what they wanted, and you can only do them one at a time. Oh yeah, if you drop one, it's careless. Awesome, well done. Worker number 1, what was it?
24.
20. Hey. You're doing faster, mate.
25.
25. Oh, it's going slower. Go on. Well, 31.
Anything pressure.
What's going on, mate? And what was yours? Andy cheated as well. I saw him doing 2 as well.
23.
I've got your card, mate. Go on.
23.
23. So everyone's slow. Right, so obviously the whole thing will be slow. What was it?
Yeah.
106.
Yeah.
Yeah, well,
106. What was the first batch?
First batch.
55.
55.
Yeah.
Okay, that's about right. Yeah, that'd be about right. So about 10 seconds. Yeah. Wow, there's something interesting going on here, isn't it? Everyone's slower, but this is faster. Yeah. Let's try this again. Let's try it with 4 batches of 5 and see if this trend continues. So this time, you still get measuring your worker, flipping 20 points, but you can pass over a batch of 5 and you can start as soon as you see the first 5. You're still timing for all 20. You're going to time when the first batch of 5 arrives.
So you're supposed to split 5 into 5s?
Yeah, into 5s, 4 5s. Now, if you happen to drop one on the floor, that's okay. I'll quickly slide one here, because if you start climbing under the table, it'll mess up the numbers.
Sandra.
I'm still saying it should take 50 seconds.
There you go. Stick to your guns.
Yeah.
All right. Ready to go?
Yep. Ready?
Go. Look at this now, he's onto it. He wants to beat that time, but doesn't want to be slow a second time. Just it's embarrassing, mate. Well done. Definitely faster. You can see there's a rhythm going now. Look at this. This is faster this time. Yeah. Look at that. We've got a fired up team now. Obviously the bonuses make the difference. Right, so worker number 1. 20.
Assistance.
24.
24, a bit faster. Well done, mate.
25.
25, a bit faster. Yeah, well
24.
Done. 24. Slower.
Yeah.
You're getting tired there. Oh my god. Take a break, mate. What was the first batch?
23.
23, okay, and the total? 44. So, for your, as a planning tool, I'm going to give you a set of dice. Just guess. But you're getting closer, at least you're getting closer. Right, last time, you'll love this. All the way to the end there. This is called one-piece manufacture. Now, health and safety, you're going to need safety goggles for this one, because they're going to go all over the place. You just flip and pass. As soon as you see one, you pass. As soon as you see it, you pass. You're going to measure your worker for the whole 20. You're going to measure it when you see 20. As soon as the first coin gets to the end, you're going to measure it. Pro tip, it's about 3 seconds. So we know that's going to be about 3, but Sandra, what do you think for all 20 to be flipped?
It's like 30.
There you go. How do you feel about that, guys? No pressure at all. Okay, number your fingers up, and ready to go, and go. Well done. A round of applause for our work. Well done, guys. Thank you. So, worker number 1. See, 21. Obviously, self-improvement there, mate. You want to just beat it, right? Worker number 20, what?
24.
24, okay.
26.
26.
25-ish.
So you've got slower and slower as you go.
Very tired.
The first batch,
4.
4, and total 30. Get a load of that. 30
Yay.
point I'll give you for that. High five, planner, finally. Saved it right at the end. That's played out as I expected, actually. So what patterns do we see here?
People get tired.
Yeah. Well, you did get slow. It wasn't your fault, actually. It happens, especially the person at the tail end, because there's a compound effect of all of the little delays, and they build up at your side. So as fast as you can go, you'll always get slower. What else do you notice?
There's more overhead when you hit them in batches of 5.
Yeah, there is, because because the smaller batch is smaller, the handover overhead increases. But if you measure each individual performance, it tends to go down as we lower the batch size. But does the customer really care how efficient we work, or do they care about this number here? This one, right? So the first instance, it was 136. In this condition, it was 30 seconds. So that's 30%, isn't it? It's less than a third, actually. Less than a fifth, actually, 20%.
No.
Less than a quarter.
Right.
It's a lot smaller, isn't it? It goes down. Now that is strange for one reason. When you lower the batch size, I know there was an overlap and that's part of it, but when you lower the batch size, you have an increase in flow. Traditionally, management theory would tell us to focus on efficiency, but in fact, if we focus on flow and the pull system, you get more throughput, and that's what the customer really cares about. And once you've got the throughput, then you work on efficiency, and efficiency can go through the roof. This number here, what does this mean?
The first delivery.
Exactly. Why is that important? Why is that important? This number here, this first batch.
Something to the market. So
Yeah. So,
See if the coin is indeed lucky.
yeah, yeah. Well, yeah, right. So in this case, because what would really happen in a production line is you'd do 20, and when you pass them over, you'd get another batch of 20, and so on. So you wouldn't be idle for the rest of the time. And in this case, so there'd have been 20, 40, 60, 80 in the system, and we'd deliver 20 after 1 minute 36. And let's say the customer said they don't work. Somebody's been doubling up, right? They don't work. So, so I'm going to reject them all. So we've lost 100 coins. If that happened in this instance, we've got 4 in the system and 1 delivered. So we've only lost 5 coins. So there's a difference between wastage of 100 defects and 5 defects. And that's really, really important. That is what Toyota really picked up on, which is why I'm going to go to this. It's also, so it's good fast feedback. Also, it's when you get paid. Let's say that we were talking months for each one of these stages, and it could take you say 1.5 years versus 30 days. Or however it works. I know there's no 100 days in a year, but you know what I mean. My maths has gone today. So it actually means you get paid sooner. And we know money is cheap at the moment internationally by historical standards. But in the 60s and 70s, money was really expensive. The cost of money, inflation was really high. So if you had things in the system for too long, by the time you sold it, you had to sell it for less than it cost to build it, and you couldn't keep up with inflation. So this is why manufacturing really picked up on this in the 70s, because of hyperinflation and because of the cost of money. So that's really important. So this explains to us the principles of flow, the principles of lean, and the fast feedback, minimizing the WIP, and all of those good things. And it leads me on to tell you a bit about Toyota. Here is a production line. So Toyota pioneered this one-piece manufacture. It'd gone on for hundreds of years before that. So the Venetian Navy back in the 15th century used to build ships one piece. In the First World War, after Gallipoli, I don't know if you know this story, so Churchill was the First Lord of the Admiralty, and he sent all of the Kiwis and Aussies into Gallipoli. And they found out straight away that they weren't able to land fast enough, so they said, right, let's build some flat-bottom boats, some shallow boats that can do what they call as landing craft. So very quickly, they built these boats 1 month after the next, really quickly. And there's one of them actually is on show in Portsmouth if you're ever in the UK. So that was one-piece manufacture. After the First World War, Henry Ford took this up as well, and the Ford Model T was the first mass-produced vehicle, first example of mass production. And then Toyota, after the Second World War, pioneered it and called it the Toyota production system. Here's a production line, and so my history was in electronics, fast-moving consumer goods. About 15 years ago, I was working in China, making headphones, noise-cancelling headphones. So I had 50 operators. I was a production engineer. And so this person here, maybe they were soldering the speakers into the wires, and let's say they take 5 minutes to do it. She then passes, I say she, it's mainly female Chinese workers, she passes it over to the staging post, and this person here picks it, and then spends, let's say, 7 minutes, and they're maybe clipping in, gluing in the outer ear cups. She passes it here, onto here, they're putting the headband on, that's another 4 minutes. Here to here, let's put the wrapper around it, that's another 5 minutes. Oh, and this person has to put it in a box, that's going to take them 6 minutes. So, That's how long it takes to build a set of headphones. We're 50 people, it took quite a long time. Question is, how long would it take for the first headphone to be ready to ship? 27. How do you get to that number? Just add it all up, yeah. So that's called the cycle time. And that's, if you do value stream mapping, that is the end-to-end cycle time. And that's an important number to know, and we measure our cycle time here in Freedom. The most important question now is, when does the next headphone drop off the line? Give me one number. So how many minutes after the first?
33-ish.
No. So
6 minutes later.
6 minutes. So you say 6 minutes later?
Yeah.
I hear you say 7 minutes later.
5
You say 5 minutes?
7.
7? So go on, tell me why you think it's 7.
The biggest number is going to be the one sliding down.
Perfect, so that's exactly right. And this is called now the takt time, which is 7 minutes. Takt is a German word, as in a metronome, tick tack, tick tack. And so every 7 minutes something drops off the line. And the reason is it's controlled by this. And we have something called theory of constraints. And the whole line is driven by this. So the takt time, let's say these workers get paid $1 a minute, for example. The cost to manufacture for each unit is therefore $7, because you're paying these people whether something's dropping off or not. So you just multiply the takt time by the dollar per time amount, so it'd be $7 a minute. How can I make this cheaper? How can I reduce this number here?
Break it down further into smaller
Batch size, exactly. Well, what I would do, 5 minutes is generally, at least when I was working there, 5 minutes would be generally the sweet spot of what workers work on. But this 7 minutes here is a problem, because this person works for 5 minutes. She puts it on here. This person works for 7 minutes, so she's now working on the next piece. But she can't put it in this box here because there's already a half-built headphone here, so she has to wait. And that's what they do, is they fold a hand and wait. Similarly, this person spends 4 minutes taking it to the next stage, and then they have to wait 3 minutes for this person, so they're waiting there. So these people are idle. But I'm not concerned about them, I'm concerned about this person who's working frantically to keep up with everyone else. So why don't we make her life easier? Why don't we make that 6 minutes, make that 5 minutes, and all of a sudden the constraint becomes 6 minutes, and we've saved $1, 1 minute off this. And that is significant in the cost to manufacture. And as a production engineer, that's what I would be constantly doing, is as soon as you remove this constraint, another will pop up somewhere else. So you're constantly seeking out where the constraint exists. You subordinate all other components, it doesn't matter about those, and you spend all of your time on one thing. You'll get to a hard floor that you can go no further. So let's say there's a baking oven here. You know, we have to cure the glue, and the baking oven takes 30 minutes. There is nothing we can do to make it go faster. So everything is constrained by this. Now, then I would put a business case together to say, baking ovens cost $5,000. If we have 5 of them, it's going to cost me 25 grand. It means then our takt time goes from 30 minutes down to 5 minutes. And there's a great business case. And we would do that, we'd have parallel ovens lined up. So that's what you would eventually do. Now, these buckets here, the way it works is you've got the artifact itself you're building, but you also got materials. So the speaker here being soldered in, you'd have 2 bins filled with speakers. You know, there you go, speaker with a bit of wire on it. And maybe you'd have 50 in each bin. I don't know the numbers, depends on what you're building. So this operator here, there'd be 2 cards, 1, 2, and they would work from this bin, and then as soon as this bin is empty, they would flip the card to say the bin is empty, and they'd move on to this bin. And while they're working on this bin, somebody from the warehouse would walk past, see that this is empty, fill it, flip the card back. So this card system is how you control the inventory. And amazingly, it reduces the amount of inventory. This is what just-in-time means. Because then you go back here, the warehouse, the supply chain, you know the end-to-end supply chain. So Toyota knows how many of these speakers would be in the manufacturer's factory out wherever they are. And that means we reduce the inventory, the cost of money goes down. These cards here is a billboard system. Anyone speak Japanese here? Does anyone know what Japanese for billboard is?
build a model.
No, Kanban. Technically, this is where Kanban comes from, and it's an inventory control management system. So what we're doing is we reduce the amount of inventory. If I go work back even further to 20 years ago, I worked at Sony in the UK, and in Sony they were making 16,000 televisions per day. It was one of the biggest factories in the UK for making electronics. They didn't have 16,000 times 100 days worth of stock. The warehouses would be huge and the cost would be huge. They had the local supply chain deliver almost every day. And in fact, different times of the day, because to begin with at 8 in the morning, there'd be a big queue of trucks. So there'd be a flow of trucks coming in throughout the day at one end and a flow of trucks at the other end, taking them out to distribute across Europe. 16,000 TVs a day, it was enormous, 5,000 people worked there. And it only took one thing to be missing and the whole production line failed straight away. You used to work in Venco, didn't you? They'd have done exactly the same there, right? It's smaller scale, right? But that's what they'd have done. So that is Kanban. Now, what we do here, we focus on the constraint. Remember, limit the whip, focus on flow. Now, how does this apply to you? Because as you might have noticed at Freedom, we don't make headphones. What we do make is code. We make technology. Now, you can see a warehouse filled with materials, which cost money. What you can't see for yourself is a server filled with half-done work. But it costs more. I can tell you it costs more than $1 an hour, $1 a minute. So what we want to try and do is, we know from that experiment we just did here that flow produces greater outcomes because we can deliver faster and get faster feedback. So we have a system here where we limit the whip, so we have whip limits on each stage. We use a quality system called TQM to manage when it goes from one stage to the next. So this operator here would inspect the soldering of this operator, because there'd be nothing worse than this, if it was a dry solder joint, putting everything on, building it up, boxing it up, and then finding out here that it doesn't work, because we've added value to a defect. So each person quality inspects the previous person, and that's what we do here. We have a policy, an explicit policy. So we make work visible. We can see the flow of the work because you can't see the invisible work of what you do. We focus on flow and limited work in progress. We have explicit policies and we limit the whip. I'm just going to dwell on this TQM thing here. There's something called an and-on chord. And this is from Toyota. So imagine now I'm in a Toyota factory. I'm assembling the car. And I'm screwing in the seats to driver's seat. And as I'm going, I've got my power drill, my power driver, and I get to the third bolt, and it cross threads, and it makes that real squealy sound, and everyone in the factory looks around and looks at me, and it's my fault. Now, what they used to do in American and British car factories, they would just chalk mark it and send it on its way, because they knew if you stopped the line, it cost $15,000 per minute. So the accounting method was just to keep it rolling and fix it at the end. Problem is, there were cars that were getting into the market with chalk marks. There was an even example in Fremont, California. What the guys were doing, this is funny, they would have, like in the door handle, a bottle of scotch, they'd have a swig and pass it on to the next guy. It was unionized, really poor. And then the next guy, and they'd go on. And then people were driving the Toyota in America, and they'd hear some rattling in the door. So they'd take it back to the mechanic, and he would open it up, and there'd be a half bottle of scotch in there. Anyway, so poor quality, but they would just flow it on through. They wouldn't stop the line. Toyota, that same factory, then became a General Motors Toyota joint venture, and they got all of the staff over to Japan to teach them how to work the Japanese way. And they had this thing called an and-on chord. So go back to me screwing in my seat. So I've got my production line, it's flowing through. There's a line where I start my work, and I have to finish by the time it gets to the end of the line, so about 20 meters up. So let's do it again. Screw, 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 squeal. Now what I have to do is take it off, unscrew it, rethread the bolt and rebuild it. And it's going to take a few more seconds. What I do while I'm doing this is I pull a cord and it sets off lots of yellow amber lights. So we know there's a problem. I've got a problem and I'm trying to work on it. If it gets to the end, the whole production line stops. And this really freaks out people who are hardwired to think about this, keep it going. But in Japan, the training lines, you have to pull the and-on cord as often as possible. In a typical day, in a typical shift in Tokyo, how long do you think, in Toyota City, how many times is the and-on cord pulled, do you think?
per day.
Per day, per shift. Or how many times? 100? Could be, yeah. Any advances on 100? It's in the thousands. As you're working, every time you've got the slightest problem, you pull that hand-on code and it goes amber. Of course, if you get to the end of your stage, they drop the line. Same things happens in electronics. So let's say this lady, she picks up a headphone that's a dry solder joint, she'll have a bin here, and she'll just reject it straight away. And she'll wait, the next one comes, and she'll reject that. If you get to a limit of, say, 5, they will stop the line, and they'll go, right, okay, you need to either be changed or retrained or do something. What's going on? How can we help? And I've actually had this happen. We'd stop the entire line, we've only lost 5 headphones there that we need to rebuild. The old way of thinking is keep it flowing, we'll fix them at the end, but that's poor quality. And the cost of the defects goes up as we go further down the line. Now, that's soldering. It does apply though to software. So if you've got if you're coding here and the tester is sat right next to you, and you find that defect immediately, you can fix it really at low cost. It's really easy to fix. If you write the code now, and then a few more weeks later it gets integrated into some other stuff, and then the build team pick it up, and then it goes into production, then you find the defect. It's like unscrambling the egg. Where is this defect? It's going to take forever to find it. So we want to try and resolve defects soon. So that idea of quality, building quality in, and detecting the quality as soon as possible is really important. So that's the Toyota line. The Kanban approach, so Kanban in 2009 was applied to technology, but it can be applied to any work that you do. You may have some analysis that you need to do. You maybe have to do some design and architecture and UX and all that kind of stuff. You do the dev, you do the test, and of course then you deploy, plus the technical documents and all that kind of stuff. And what we do is we want to find out what the optimum WIP limits are here. And what typically happens is test sometimes takes longer than development, especially in things like mobile apps. And what we don't want is like the WIP limit's 5 here. We've got 5 things here, and the developer goes, well, I'm bored. The testers are going to be a few more days on this, so I'm going to start coding some of the cool stuff and start building up a queue here. Because the problem, what happens is the tester never catches up. And by the time the tester gets to this piece of work here that they did 2 weeks ago, he goes, I had no idea why I did that. So what we want to try and do is, if the developer can't, if there's a holding point here, if this WIP limit is full, the developer stops, downs tools. And that really goes against what we've learned, right? Because we want to talk about efficiency, and you pay lots of money and all that kind of stuff. But we need to pull that hand-on code and say, hey tester, what can I do to help you? You're now the constraints. Subordinate everything else, what can I do? Because our output is limited by what you're doing. Even if it is, can I make you a cup of tea? Or can I sit there with you and help you resolve the defects? And that's counterintuitive. It's not what we used to do. You'd have your job, he'd have his. If you slow down, it doesn't matter, I'm doing my job, I get my bonus. But that coin game shows you that even if the slowest person is down the line, it's going to limit the whole line. So we focus on the slowest person. And that's the essence of what I wanted to share with you. It's 10 to 10. We'd normally take a quick Q&A and a break now, but what I want to do is ask you a few questions. What insight did you get out of that?
Very interesting, because I have been in teams where devs were just saying, give me more work, and not thinking about the downward flow.
That is, in fact, when we did this yesterday, one of the devs said, well, I'm here to develop, and I'm not just going to, he basically said, surely I can get on and do some more stuff that's more efficient, look busy and all that kind of stuff. The thing is, it's a different way of thinking, and we need courage and discipline to do it, and the business needs to recognise it's better for you to be sat idle doing nothing at all than creating more backlog of more defects that we don't know about. It goes against the will. So in the old American car plants, they would have sacked you for stopping the line. In Japan, and Toyota overtook Chrysler and GM, principally because of quality. And the way we can beat our competition is by going faster, by not clogging the system up. But that's really hard. It's like you have to really resist the temptation to do work and load the system and build up the WIP. Thank you. What's in your mind?
Actually, I was reading, does it call careful production, Toyota, something like this?
What's
Careful production line.
I don't understand what you mean, sorry.
Careful
Careful.
production.
Yeah.
I was reading about this on Toyota, how they invent this system before, so I kind of.
So yeah, now the thing about Toyota is interesting. It's the same with a lot of Japanese manufacturers. They really, in the 50s, 60s and 70s, pioneered all of this.
Mm.
In the last 10 or 15 years, not so great. Even Toyota, they grew so fast that they lost the essence of their culture. And so they've had a few problems in the last few years. They're now changing it around, and I'm linked up on LinkedIn with their head of Agile, who now Toyota do Agile and Lean across the organization for, you might not know this, but in a Hilux, there's more lines of code than on Facebook, right? In EU, because of all the computers and all of the hardware and firmware. So they have had ups and downs, and I mean, I really extol the virtues of Japanese management principles, and that's where Agile has some of its history, but not everything in Japan is perfect. For example, there's a culture of work until you die, literally work until you die at your desk. They're not really great at transparency, so if you read about Fukushima, it got worse because everyone was going, hey, yeah, everything's sweet, nothing to see here. And if they'd have been more courageous and transparent, they could have mitigated that disaster. So not everything in Japan is ideal, but this was built 50 years ago. The way Japanese manufacturing took over the world in the 1980s. And then, because I was living in the UK, I went to the Toyota factory in the 80s in Derbyshire. And the UK car industry at the time was on its knees. It was almost gone. But Toyota turned it around because they didn't just build their own factory, they changed the whole supply chain around it. So the UK now is quite competitive with Nissan, Honda, and Toyota.
And they have sort of Kaizen as the continuous improvement is kind of built into what they do as well.
That's exactly right. This add-on code is Kaizen, and Kaizen is something that happens thousands of times per day. It's not just a Kaizen meeting once every 2 weeks, which Motorola picks up on, which is why we've called ourselves Kaizen coaches, because I want that mindset of continual improvement. Toyota actually got Kaizen from the Americans from training within industry, which is, I'm going to give you the history lesson in a minute. So, okay, let's keep going around. What's yours?
What is the more the benefit for the Kaizen compared with the previous sprint? I mean, for example, in the different part, there has the dependency between the different part. So how to guarantee the dependency can be covered?
Yeah, dependency is a complexity problem, and what we want to try and do is reduce it, and we do that by reducing the batch size. So the simplest piece of work we do, the less likely it's going to be dependent. The bigger the piece of work, the more codependency we have. In terms of the flow, we try and simplify it because then we can focus on the problem. It gives us more cognitive space.
But like the coding, it always has some dependency. This part of the code has other dependency. How to guarantee the dependency part is not missed?
Yeah, so that comes into things like it's a good question, and actually I think peripheral to what you're mentioning here is we're building widgets, and you build one widget a million times. We don't do that in software, right? Everything is unique. But the difference is, even though everything is unique, the flow of the work is still the same. We still have to analyze, design, develop, UX, ship, and all that kind of stuff. So there is still a flow. But it is more complex, but the idea is if we can simplify part of the flow and have the basic principle of the way the work goes, then we can pick up on that dependency more easily. If we visualize the work, we can say, hold on a minute, that is dependent on this. And we may miss it if it's too large and complex and we don't visualize it. So it doesn't make work effortless. It's still hard work that you're doing, really technically challenging. But this hopefully makes it a bit easier and easier to pick up on the defects that are going to arise.
Another question, if, for example, I'm a developer, I have a big task to do. So following this approach, we need to try to split it into small pieces as much as we can, right?
You can, and it's the way you slice it. This is the essence of the hardest part of Agile, is how you slice the work. Because you need to slice it in a way that it's testable and valuable. So you don't slice front end and back end, you want to slice vertically. And that's really, really hard to do. That's the life of a BA, right? That's the biggest challenge we've got. What questions have you got?
So if the key component is breaking down there, and then say one of the person who's making headphones, they need to be retrained, and you just remove this person. And while this person is being trained, do you just to stop the whole line for?
Well, here's a
long
story.
time?
This actually happened. So I was in China because we were being checked by our customers. So the company is called Phytech. It's based in Newmarket, and we were doing the headphones, white labeling it for Logitech. So Logitech flew in from America, and I was the project manager, coordinator, production engineer, and they were watching it. And the Logitech guy said, "That lady there, she's soldering. Where's her soldering certificate?" And usually, if you're a solderer, you should have your cert to say I'm qualified to solder on the sheet. And she didn't have one, so we had to stop the line. And then they scrambled around and they went back to HR and they found it. I'm not that I'm distrusting, but typically, yeah, we would stop the line because if she's unqualified to solder, what's the point in making? I mean, we were making hundreds of thousands of these things. What's the point in making tens of thousands in a day of a headphone that are no use, that Logitech wouldn't buy? So yeah, we stopped the line, and so for like half an hour, 50 people were just sat there like that, and really disciplined. Obviously, it was quite hardcore labour going on there. They would just look at this. They wouldn't make eye contact with anyone. They just looked down like this, and I felt really bad that we were wasting their time, but we were wasting our money. But the point is, it's better not to build crap. It's better not to build poor quality, and that's the way they work. And it works. That's how mass-produced consumer electronics is made now.
My concern is if the key person is missing, and do you just wait until the replacement is found? And
Yes.
there's no other choice.
That's correct. Yeah. But what we do is we find a replacement quick sharp.
Right.
So hence they suddenly found this. They suddenly quickly trained her. I don't know. I'm skeptical, but no. But genuinely, yeah, we do. But there's no point building lots of half-built headphones. There really isn't. So, well, these were prototypes, so sometimes it is, but in theory, right? But, we have to be pragmatic.
Yes. So for some sprint, we got some work like the first maybe is a few days.
Mm.
We just focus on develop and tester doesn't really have
Yeah,
anything to
now,
test.
this is this goes back to, yeah, take a seat if you want to relax. That's a really good point. So we're going to talk about this later on, but you know the old way of doing work is, we know waterfall, right?
Yeah.
So we do all of the analysis, we do all of the design, all the development. But now today we do Scrum, so we do everything in 2-week sprints, like that. And then if you look in the 2-week sprint, you have 4 days of analysis, 3 days of development, 2 days of test. So what we're doing is just mini waterfall in 2-week blocks. That's not the way to think. What we'd ideally do is slice it so thinly that on Monday, on the first day, in the morning, we are developing it, and the tester is set next to the developer. Then we test it and resolve the defect and ship it by the afternoon. And then the next day we do another one, and the next day, and the next day. What I've seen many teams do is on the first 3 or 4 days the tester's sat idle, and then on the last 2 or 3 days the tester's really stressed and the developer's bored, so they start developing more stuff. So it just becomes a mess. So that requires discipline and an understanding of how we slice. If there's one thing, there's 2 things you can take away from today is a mindset, the way you think, and secondly, the habit of how you slice your work, and that's the biggest challenge.
Yeah, that was a good illustration of, especially the coin thing, breaking it down. It's probably something we've thought about before, but I wonder if we'd be looking to move towards releasing more regularly.
Totally. That is our biggest constraint here at Freedom, is we only release 5 times a year. So you, in essence, it's a 10-week sprint you do. And so sometimes you're doing UAT days is going on shortly. And you're going to be user acceptance testing something that somebody did back in October. Yeah, so it's not great. Hello. That's okay.
I just missed that little, it's not really that super important, but that little the billboard thing, then you talked about the inventory.
Yeah.
And how that became Kanban. Can you just explain?
Yeah, so Kanban, when Toyota got Kanban, they were actually inspired by a company called Piggly Wiggly in the US. It's a supermarket. And in the US, the supermarket, you go in, you go, oh, I'll have some lettuce and tomatoes and that, and you pull from the system. They don't typically have a year's worth of lettuce in the back, because it doesn't really, it goes off after 3 days. So what they'll do is you'll have a bit of food on display, and then in the back of the shop they'll have a bit more, and then the shop's warehouse will have some more, and so on. and they pull the system through. And that inspired Toyota. And they looked into spas, hot spas in Tokyo. And you go into these hot spas at the end of a working day, and everybody descends in, and it's not a great experience. So what they have on the outside of the spa is wooden tags. And as you go in, you take a tag, and you go in. If you go to the door and there's no tags, you're not allowed in. And these tags were billboards, were called kanban. And in essence, they're trying to do the same here, because they know if you've got thousands and thousands, if you get a year's supply of speakers, it costs you money that you have to pay up front. And in the 70s, that was really an issue. But secondly, it clogs the whole system up. So the way you minimize the amount of inventory is by having this pull system. And the way they visualize a pull system is through the billboards. So they just have red and green cards, and you flip them. And Navman, where I worked here in New Zealand, do that. Many electronics manufacturers use this now, and it was pioneered by Toyota. But Kanban means signboard or blackboard.
I've got a few questions.
Yeah.
So the example you used for Dave passing to test and getting bored and doing more, creating a backlog essentially. Isn't it more efficient to solve that problem by having test capacity increased temporarily?
Yes, it is. Remember, efficiency isn't our principal focus, but ultimately we want to become more efficient. What I would do here, let's say we've got one tester and 3 devs, and we've got 2 devs sat idle. Well, there's no business value in that. So I would be saying, well, how about having fewer devs or more testers? I'd prefer to have fewer devs. Or what can we do to make the tester's life easier? Can we automate? Is there some part of the testing that the devs can do or other people can do? Perhaps if the tester sat next to the developer, they can pick up the defects more immediately and understand if they're developing their test scenarios alongside the developer, maybe they can be more effective. Maybe there's some work that testers are doing because they don't understand the full context of what the dev's doing. Because if they work as a team, you can be more targeted with the testing. So we get the testers to do less work. So rather than, we could get more testers. That would be possibly one solution. My ideal solution is to have the same number of testers but do less work and give them fewer defects as well. That helps. So that's a different way of thinking. We are hardwired to think, well, all of our clients and partners at the moment, we need to do more work. Why don't we just get more teams in? But that increases complexity. It doesn't immediately solve the problem. Right, and it's important you're an architect. The idea is you don't do all the architecture up front. You sit with the dev and with the tester, and it emerges as we go. Or you,
Sorry, can I
double the, yeah,
can
so
I ask one more? Sorry,
you can certainly.
On the cascading waterfall,
Yeah.
the way you described the sprints with vertical slicing, the lead up time until something actually gets to test and all that. Let me just get my thought process back. What I was going to say is with vertical slicing, you were saying you want to slice it as thinly as possible, right?
Mm.
But from what I've seen, that generally leads to a lot of rework, because those thin slices deliver something that's not the end product, right?
Indeed.
Something's going to be built on top of it, and then something else is going to be built on top of it until you reach the final result.
And
So
it
the
is an
initial
efficient.
testing effort, I'm not saying it's not valuable at all, but I would question its full value, right?
There's a sweet spot. So we say 5 minutes here. I mean, we could make the batch size even smaller and make it 2 minutes. How about 1 minute? How about 30 seconds? How about half a second? There becomes a point when it's less efficient. You're right. When you slice, it means there's some inefficiencies built in. However, there are ways to mitigate that. And the benefit of the flow and throughput over efficiency it's a trade-off. And I would people cognitively tend to build a batch up to be more efficient. And all I'm saying is lean against that and try and be focus on flow before efficiency. But then you have to consider efficiency too. And maybe there's ways of automating testing or especially in architecture, looking at just a broad outline before doing the focused architecture. But you're not wrong that there is an inefficiency inherent in that.
I'm just thinking of the slowest person on the line.
Yeah.
Probably, yeah, maybe we know that one of the reasons probably is that person is untrained. Then we need to
It
do
could-
some
it
training.
could be training.
Okay. And probably one other reason is could be he wants to make sure that his output is not failing when you go to the next line.
Yeah, and that's okay, right? So we want to go slower in order to go faster, because slow is smooth, smooth is fast. But and those two are good reasons why that's the slowest person. But it could just be that this person has more work to do. So soldering a soldering speaker may take 5 minutes, but even the fastest person in the world, to screw in like 8 screws on each ear cup may take 6 minutes. There's no way we can reduce it. So sure, some people are always going to be faster than others. We want to get some kind of cadence and urgency to it, but this may be, if we go to this oven, this heat treating oven, the heat treating oven just takes 30 minutes. There's nothing you can do about it. So the only way to mitigate that is to invest in parallel ovens to speed it up. If that person needs training, then of course that's the constraint, is inadequate training. If that person is being too conscientious with quality, and that's possible, then training again. And maybe they're being too conscientious because they don't trust this person, because this person's quality isn't great. So maybe we have to train this person, so this person's job is easier. And that's my job as a production engineer, is to do root cause analysis of what's slowing this person down. And I would literally be stood over people with stopwatches and working out why they take so long. And then I'd have a standard saying, you're taking 6 minutes now, I know other people can do it in 5, so what's going on?
Yeah, just thinking the one that I've asked earlier about how do we measure our effectivity, or how do we know if we are successful in our process. And I heard about throughput, about the flow versus efficiency. And I wonder, freedom, like what is our ultimate goal to begin with?
Well, that's a really good question. Well, and one to be directed at Russ. What's our ultimate goal is to satisfy our partners. So it doesn't matter how efficient we are. We could be the most efficient company in the world, but if we're churning out stuff the customer doesn't want, who cares? So we need to satisfy our customer so we get paid, ultimately.
Right.
And so we've got to be really careful what we measure. And there's 2 metrics, actually. This is well over and outside of this training, but I'm into this kind of stuff. We did some metrics about a year ago at Freedom. And the 2 things that came out were reliability and effectiveness. Now, if I'm unreliable, it's when I say I'm going to do something and I don't. So if we say we're going to take 27 minutes and we take 30, there's an unreliability. And you can apply throughput dollars to that. So that's $3 late. And the other thing is effectiveness. That's where, if I'm ineffective, something that I don't need to do, but nevertheless I do. That's where we deliver things that the customer doesn't want. We're gold plating it. So we need to be more effective by doing the bare minimum effort in order to satisfy the customer. And we need to be reliable, which means being on time and meeting the quality and all of those good things. So we've got to be careful we don't measure the wrong things, because if you measure efficiency, these guys would be, well, I did it in 1 minute, give me my bonus, even though it's crap quality. So we've got to be very careful which metrics we use. And the guy, Theory of Constraints, this guy's called Eli Goldratt. He wrote a book called The Goal 35 years ago. And he talked about the 2 metrics that you look at, effectiveness and reliability. And all others you've got to be careful about. And if you have more than 5 metrics, you're going to game them. People will game them for personal gain, of course. Human nature. We're not bad people. Right.